we go. Okay. All right. Which number did you say? 22. 22. Let's do it. Okay. 22. The absolute value of n minus 3 equals 5. All right. What do we do? What's step 1? No, we can't add 3 yet. We got to deal with the absolute value. Yeah, we got to split it into the positive one and the negative one, right? So we got to split it into n minus 3 equals 5 and negative n minus 3 equals 5, right? Now we'd add 3 on this one. What are you saying? What's not negative? Are you saying this shouldn't be here? Is that what you're asking about? This one? No, because it doesn't change all the things in here. It would change the whole number to a positive. Yeah, so it doesn't, so the positive version is just this without the absolute value, and then the negative. And remember, this works because if we have just absolute value of x equals 5, then x could either be 5 or negative 5. Because what's the absolute value of negative 5? It's 5. So that also works. So we have to split it into the positive version, which is just this, and the negative version. So the negative of all the stuff in here could also equal that. Okay? And then yes, we do add 3 on this one. What about this one? What will we do over here? Divide by negative 1 is totally fine. You could also distribute it either way. You'll get the answer. So over here we end up with n equals what? 8. Over here, what do we end up with? Now what? Add 3. So n equals what? Signs are different. Signs are different. So we subtract and keep the sign of the bigger one, right? So negative 2. You did. It was in there somewhere. All right. What other questions do we have? 32. 32. Okay, we got a Venn diagram, whatever I'm trying to say. Pie chart. No, not a Venn diagram. Pie chart. I love Venn diagrams. Isn't that what Kamala Harris said? I love Venn diagrams. I think so. All right, so for competition, the cheerleading team is preparing a dance routine that must last 4 minutes with a variation of plus or minus 5 seconds. Find the least and greatest possible times for the routine in minutes and seconds. So if we take 4 minutes and we add 5 seconds to it, what do we have in minutes and seconds?
1 minute and 5 seconds.
If we take 4 minutes and add 5 seconds to it, 4 minutes and 5 seconds. You said 1. I heard 1. So
I meant 4.
So for part A, this is, what number was this? This is 32?
Yeah.
32A, 4 minutes and 5 seconds. And then also the smaller number, if we take away 5 seconds, what would we have left? 3 minutes, not from this, from the middle. 3 minutes and 55 seconds. And then part B asks to write these numbers, but in seconds. So how do we convert minutes to seconds? Do something with 60. for sure. So we got 4 minutes. We're trying to cancel the minutes, right? I'm trying to get seconds. How many seconds are in a minute? 60. Good job. So we put our 60. So multiply by 60, right? Because they're both on the top. So what's 4 times 60? 240. And then plus the 5 seconds, right?
245 seconds.
True facts. And then we do the same thing over here. So what's 3 times 60? What's 3 times 6? Yes, 180. And then plus the 55, so 180. I don't know why I'm writing it a mess, sorry. 235 seconds. Easy peasy. All right, what else?
34.
Thought you were going to ask about 34. Thought I heard you say that. Okay. Corbin beat you. Okay. So we got a number line. This problem right here is what absolute value is. This is really what it is in a practical sense. Okay? So we want an equation involving absolute value, and it gives us dot at -6 and 6. You asked about the easy one. You should have asked about 36. Maybe we'll do that too. Okay? So absolute value is distance from a point. So what is the middle of those two numbers on the number line? 0. So distance from 0, right? So the absolute value, now what distance from 0 in each direction?
Negative.
What distance? Distance is positive. What distance it's away? This is like I said, this is the easy one, right? Absolute value. So the absolute value of x, and it's just x because it's not shifted from the middle at all. It's not shifted from the. Let's look at number 36. That's going to be a little bit different. This is the answer on 34. Easy peasy. All right, but what about 36? Because 36 is a little bit more complicated, only slightly, but a little bit. I'm surprised this was not the first one people asked about, but you know. So between -6 and 2. Okay. So this time the middle isn't 0. These numbers are offset not from the middle of our number line, but from somewhere else.
4. Negative.
Well, let's count in and see. Right? 1, -5. I'm not equally spacing, I'm sorry. It's going to mess with somebody. 0, -4, -1, -3, -2. -2 is the middle, right? So we count in. That's where we end up with, right? So how far from -2 are those numbers? 1, 2, 3, 4. Also, if we do distance, right? 2 minus -2, what do we do with that? We ka-chink. 2 minus -2 is 4. So either way, just counting or doing the math, we get 4 as the distance, right? So it's a distance of 4. So we're going plus or minus 4, so that's what the equation is going to equal. Because that's the up and down bit. But this time we need to inside the absolute value. It's not just going to be x, because if it was just x, then that would be at 4 and -4, right? Because that would be the middle would be there. So we got to add some stuff inside of there. So what would we add inside of there? Do you think? What is the other number involved in this thing? The negative 2. So what do you think we put in the middle?
Negative 2x.
That's a good guess, but definitely not times. That's right. I was hoping you were going to say it wrong, but that's right. It is x plus 2. Okay? Even though it moved to negative 2, the sign's going to be opposite. Because and I'll show you by kind of working this problem out, if we split this into x plus 2 equals 4 and negative x plus 2 equals 4, and then we subtract 2, we get the 2, right? So it's opposite because we gotta do the opposite to get rid of it and move it over and do all those things. So that's why it ends up being opposite, right? So that's how those work. So just to go ahead. It'd be x minus 2. That's right. That's right. So let's look at, just to make sure you understand what's going on these, because this is a topic that I need to go back and add in a video, because that's not in there, right? So let's make sure you have it by doing 33 and 35 together. Okay? So what would 33 be? You need your book because you didn't write it, because we didn't assign it. Absolute value of x, right? Yeah, because it's centered at 0, and it goes up 4 and down 4, right? What about 35? I'll draw it on the board while y'all look.
Absolute value of x minus 1 equals 5.
Absolute value of x minus 1 equals 5, he says. I don't think so. Look again. At least that's what the key says you're wrong, but we'll find out. Yeah, you're wrong. You're totally wrong. What's the answer? I know where you got the 5 from. Let me tell you where you're confused and what happened. Okay, you got the 5 from this guy, yeah? But if I go up 5 from 1, where am I? I'm at 6, not at 5. If I go down 5, I'm at negative 4, so that's too many. So I'm actually going up 4 and down 4, not 5, right? So it would be the absolute value of x minus 1. You did that part right. Good job. Virtual high five. Good job. But it equals 4 because we went up 4 and down 4. Make sense? What other questions do we have from this lesson? Well, the instructions say solve each equation, then graph the solution set. So yes, which means we need graphs, which y'all need. Oh, these are not inequalities. So you just draw the line and put the dots on them. Yeah. On that grouping, you got those wrong. So which one?
23 through 42.
You got every problem wrong.
Yes.
Okay.
I didn't do the second.
Did you watch the notes video?
I did, but
It's because he asked why you didn't split it too.
I know, and he just said that. I heard him. Okay, so do we need to look at some more of them? 38 through 42 are definitely more challenging ones. Do we need to look at some of those? Okay, which one? 42. Yeah, 42 is probably the most scary looking, right?
That's what I said.
Yeah, 42 is, it's not hard, but it's definitely scary. Okay, so our goal with the absolute value equation is we want to be able to split it into two, but we can't do that yet. Because in order to split it into two, the absolute value's got to be by itself first. So first we got to solve for the absolute value of p. So what do we want to get rid of first? 12, I agree. That's a great idea. How do we get rid of the 12? Subtract 12, both sides. So 4 over the absolute value of p equals 2. Okay, now we got a big old issue here, right? We got 4 on there, we got absolute value on there, and also the p is down in the bottom. So we need him not to be in the bottom anymore. So how do we get him out of the bottom? Multiply, not 4, but you're thinking right. By p, yeah, by the absolute value of p, absolutely. So we can do this, because over here it's going to cancel, right? And then over here, it's going to be there. Over here it goes away. 4 equals 2 times absolute value of p. Now what? Divide. By what? 2. Good job. You fixed your error from last week. Virtual high five. Way to go. Way to go, buddy. You're rocking it. So the absolute value of p equals 2.
Can we do 40?
What?
Can we do
I'm not quite done with this one technically, but then yes, we sure can.
sorry.
Because what do I got to do now? No, I don't circle it yet.
Take it out of it.
I can't just take it out. I got to split it into 2, right? P equals 2 and negative p equals 2. Right? That's how we get rid of absolute value. Split it into 2, right? P equals, and we could even write this one in a fancy way. We can write it as plus or minus 2. I don't know why my 2's are going nuts today, but they are. Cool beans. Now 40 is what you said? Sure. Yeah, sure.
Yeah, for some reason I just screwed it.
Yeah, you can't do that because absolute values, they are grouping symbols, but they're specialized grouping symbols. They're a grouping symbol with a purpose that's not just to group. So can't get in there until you split it up. 2 times absolute value of h minus 3 equals 8. So, same thing. We can't do the splitting until we get the absolute value by itself. So what do we need to do? Add the 3. Absolute value of h equals 8 plus 3 is 11. Now what?
Now divide the 2 off.
Divide the 2 off. Absolute value of h equals 11 halves. Split it into 2, and so h would equal plus or minus 11 halves, which is the same as 5 and a half, right? I don't know what I'm doing.
5.5.
That's true, it'd equal that too.
I thought you can't take the letter out of this.
I split it into 2. into the plus or minus. That's what I did. X equals positive 11 halves, and H equals negative 11 halves. I just smooshed them in with our cool new fancy plus or minus symbol. Okay, what else? $34? Okay.
Did we do that already?
Yeah, we did.
We also did 32, which is what you said, right?
No, well, we did do that about how
We did 32, 34, 36, 33, and 35. We did all of those.
Okay.
What else? Take a quiz.
Yay. I'm ready.
This is quiz 3, I think. Unless I've given y'all back some quizzes. Have I given y'all back some from this lesson?
Not from the one we took on Tuesday. No, we haven't.
Because I only have 2 quizzes, so this is probably quiz. Even though that one's labeled, one of them's labeled quiz 2 and the other one's labeled quiz 4. So maybe this is quiz 6. Let's call it quiz 6. Let's do it.
Well, I think I'm about to I always label it as the lesson.
Oh.
The lesson number, not the
Okay, so in Gavin's numbering, this is quiz 2-5.
Yeah.
Okay, page 106. Numbers. Let's say 23. And
33.
27.
Let's do 33 because we already did 30.
And 29. There you go. Okay. So when I do that, what's left on the left side? Nothing. What do you mean nothing? 3BZ, yeah. That's what's left.
Yeah, totally.
And on the right now, are these like terms? Yes or no? No. So we can't smoosh them together. We just got to write them out. Now what's still attached to the B?
The Z.
The Z and the 3. They're attached the same way, so I bet we can go ahead and get rid of them at once. Now this is gonna make something a little bit tricky in a second. But we got this. We can do it. How are they attached to the B?
Multiplied.
Multiplied, so we get rid of it how? Divide. Now,
3B.
I'm gonna no by 3Z. We want B by itself. So we're leaving the B where he goes. I'm going to write division a little bit different. How can I write x divided by 2 differently? This is just a different thing. There's another to that. How can I write this differently? No, not that, but that's a good thought. This is the same as 1/2 times x, right? Division's the same as fractions, right? So and we'll see why in a second, but I'm going to write this as times 1/3z. Okay? And we do it on this side, we've got to do it on this side. Now look here. It's 1/3z times everything, right? So what's left on the left?
B.
B, and B only, right? Which is great. We're basically at the through spot. What do we got to do with this, though?
Write it down.
I did write it down. What do we got to do with it? Was this 1/3z times all this mess? What is that going to do? If this was a 4, what would we do with it? Yeah, distribute it. Absolutely. We've got to distribute that in there.
Guys, this is just for video.
Yes. So what's 4a times 1 over 3z?
How was it?
How do I write 4a as a fraction?
4 over it.
No.
Or-
4a over 1,
Oh.
right? So 1 times 4a is
We got letters on here, but not those letters.
1 times 4a is what? 4a, thank you.
4A.
1 times 3z is what? 3z. What is 1 times x? 1x, or just x, right? And what's y times 3z?
3ZY.
3zy or 3yz, either one.
3ZY.
And now we're finished.
I don't.
I said it wasn't very difficult. Let's do another one. Let's practice some more.
Okay, it's fine. I think I could. Hopefully.
Let me do a real one. Yeah. What science classes are y'all in this year?
They're in APC, we're in biology.
Biology's useless to me. That doesn't have cool enough equations. IPC is maybe.
Unless you can be a doctor, you can know biology, chemistry, and physics.
Yeah. I don't like biology. I think it's boring. But I like chemistry and physics.
Only because it has equations. No one likes chemistry.
What am I writing? Physics.
I love physics.
Physics is great, yes.
Physics is I like college.
Yeah, that's what I want right there. Let's do this one. Should we do it with the subscripts? I think we should. Let's make it exciting. We'll solve for a simpler variable. Actually, no, let's do. Oh yeah, that's good.
They're dying with our patients.
Mom, that's not working. None. I'm gonna go get my bags for some.
So that already happened.
I swear.
Questions?
Oh no.
For,
Yeah, it's not that hard.
What's that thing?
let's say A.
B.
No.
Go ahead and get it copied, and then I'll explain what those are.
No, but
They
is it
are.
like a circle? Is it?
It's a 0.
It's a 0.
Did you write it all down? Good. This is a velocity equation from physics. No, not chemistry. Physics.
This is called physics.
We might do. Actually, there's a really good one from chemistry that we could use in a second. Be great. PV equals nRT would be perfect for this, and it would also be easy. Okay, we'll solve this for A. Okay, so the question is what are these? Those are subscripts, and all subscripts is a more specific variable. So this is and typically in college and in high school, if you have a cool teacher like me, we say subscript 0 as naught. Not. So V naught, and this would be R naught, right? So like, for example, this V naught is the initial starting velocity of whatever's going on in this problem. This V is the final velocity, the ending. So there's two velocities, and we put a subscript to make it more specific. To be like, there's two different V's happening. But instead of writing like I or something like that also has some other meanings, we use subscripts, right? So that's all that means. So V naught is just like X, right? That's all that means. Now we need to solve this for A. So what should we get rid of first?
The V naught.
The V naught squared. Yeah, I love it because it's easiest to get rid of the addition and subtraction first, right?
I literally just guessed. I was like, I don't like that.
So if we were like trying to solve, like if we had numbers and we were shoving stuff in, and we were simplifying this, then yes, we would start with that. But we're trying to get stuff off of here. So it's kind of different than order of operations, right? So how would we get rid of the v naught squared?
Minus it all.
That's right. Subtract it off. Subtract v naught squared.
I have a question.
Yes, sir?
If you wanted to, could you distribute the 2a?
You could, but that's kind of, in this particular problem, because that would be going backwards, because then you'd be mixing a in here and whatever else, and we'd actually end up having to factor it back out again, and so we'd be going around in circles. But that is a possible thing to do. It's legal. It just would be going backwards in this particular problem. So, are these like terms? Are these like terms? No, because one of them's v and one of them's v naught, right? So we got v squared minus v naught squared equals 2a times r minus r naught. It's not squared. Oh, funny. Now what?
Now the R.
So there's kind of just two things that are attached to a still. There's the 2 and then that chunk, right? Because that chunk is all there. Yeah, so let's go ahead and divide 2 off, right? Why not? Divide 2, right? So we've got v squared minus v naught squared all over 2 equals a times r minus r naught. Now, how is this whole chunk attached to a? Is it added, subtracted, multiplied, divided, something else? That whole chunk is multiplied, so we can divide that whole chunk away. And then this side, I'm going to write it as this, because it's going to be easier to see what to do with it, right? So what's the top of the answer going to be? The numerator. V squared minus v naught squared. Absolutely.
Not squared.
And then what's going to be in the denominator?
2. I mean, no. R minus
R minus
R
times 2. 2R.
Okay, what just happened? What did I do?
There's 2 2s.
What did I actually do? I distributed the 2, because the 2 is times everything. Yes, you can also draw your little loopies underneath. Those are just helping. Those are just helpful tools. Upside down. A equals.
you can do upside down?
Yep. So it's really important that you get in your head here, because I get folks on a test or on a quiz on this topic that will still somehow magic out a number answer because they're like, this can't possibly be right. These problems are going to have expression answers always. Don't get scared and start somehow trying to magic numbers out of this. Right? Let's do one more that's easy, and then maybe I'll let you go a minute or two early.
No, it was like this. See the problem?
Let's do a chemistry example.
He's like, see the question, just.
This one's super easy. I'm gonna let you do this as a guided practice.
And then it's just like 10 times harder than the other.
I should probably not.
This is the ideal gas law equation. Yes, sir. I don't know if you learn it in IPC, but you learn it in chemistry. You learn it in chemistry. It's actually a really easy equation to use in chemistry. Most of the math in chemistry is honestly pretty easy. It actually only takes one step to solve this one. Absolutely. That's exactly right. Did you do it, Gavin? Did you solve it?
I finished it.
Well, I said
We'll solve it, bro. How are the R and the T attached to the end? Yeah, so how'd you get rid of them? There you go.
What?
RV. Where's your RV?
He said RT.
Oh, that looks like an RV. That is an RV.
Where?
V.
Yeah, that's a P.
That's a, your
Look.
question mark.
You basically just took one of the RTs out. Wait, what? Or just one of them together, excuse me. No, not two one.
That.
Easy peasy.
What?
Did you get something different?
No.
Turn it on silent, and then you won't have this problem.
I was, but.
I see.
Oh,
Did you get something different? Did you get something confused? What? Okay, good. That you were acting like you were confused. I didn't quite understand what was happening.
I was confused why this kept beeping because I turned it off.
No, you were acting confused before that did it. So I don't know. Who knows? It got repaired though, right?
Yes.
Okay, kids. I think that's good enough for today.